year courses. So when you're in first year, it's kind of hard, especially those are in EECS. Sometimes it's hard to choose between whether you want to go into computer, electrical, or sometimes computer software. So we try to make sure that before you get into it, you kind of know what it's like, so you have an experience of looking at it and decide for yourself which one suits you the best and which one interests you the most. And we'll do the Q&A session now. Yasser, you want to start?
Okay.
We can do one question each, so you can start with the first question. I'll do the second, third. You.
I'm just getting the microphone. So.
Yeah, sure. I think Yasser is having some technical difficulties, so I'll take over for him and I'll start this Q&A session. So first of all, to introduce the professors, Professor Jackie Wang is an assistant professor in the teaching stream, so that's why you will see him teach a lot of courses, especially in software engineering, and I think he also does some overlapping CS courses. Professor Sebastian does usually electrical or computer courses. He's an associate professor, and as Harshit already introduced, he's the program director. So just for starters, how long have you been at York?
Well, I've been at York since 2013.
For me, if you say teaching, I have taught since 2017, but I was a York undergraduate here. So since year 2001, so it's been a long time for me. But if you say teaching, 2017 since.
So you were basically at our position like once upon a time.
Yes, definitely. It's a long time ago. Long time ago.
So what upper courses do you teach and what can we expect from those courses?
Sebastian, you want to go first?
Sure. The courses that I teach are 4201 computer architecture. And I've also taught, and currently I'm teaching 4612 digital VLSI. And what you can expect from those courses is to learn from 4201 some deeper organizational details about how computer processors are architected. That is how they interact with a program at a lower level, how they take data, and how they try to execute those instructions as quickly as possible. So the techniques and limitations that people use therein. And in the VLSI course 4612, you learn how to build circuits that can be used to construct large digital systems. So this would be circuits consisting of probably 10,000 transistors and up.
So for me, so far I have been teaching courses at different years. If you say the upper year, in the third year, I've been teaching 3311, the software design course. It's a challenging course, very heavy workload. I know students talk about it, but I think it's a very useful course. You learn about software architecture, you learn about design by contracts, many useful stuff. Because usually students, before they take the internship or co-op, they actually take that course. But I think that this term, my other colleagues are teaching it, so I'm not teaching it this year. I taught it in the fall, actually. So I think it's a very foundational course. I think at some point of your study, you will definitely encounter that. It's a very good one. And the fourth year course, the the one I taught is called Compilers and Interpreters. It's 4302. This may not be a required course by your curriculum, but if you got any scope to actually choose an elective, I'm not too sure if that's possible, but you can think about it. So that's actually a course about building compilers from scratch. So what's a compiler? So briefly speaking, compiler is basically just a program to really translate from one program to another. For example, you can write a compiler to translate from Java into C, or maybe translating from C into Java or to Python. So you have to define your grammar, very fun process. And then once you define the grammar, you can implement very exciting tools to really analyze the grammar and then process the language. So just for example, so we haven't really taught this course for a long time in the EECS department, maybe since year 2005. And guess what? I was in that class in year 2005. And ever since, they haven't taught that course anymore. And then I picked up the course last year in winter 2020. And then actually, we actually got a very fun, at the end of the semester, very fun projects. So students design their own language, and then they try to basically translate their own programming language into some construct that can be verified for correctness. So that's, yeah, it's a very useful tool, useful course. If you ever get a chance to choose as an elective, that'll be useful for you. Okay.
What's the course code again, Prof?
It's 4302.
Thank you.
For the next question, so what do you expect that students can take away from the course content, and evaluation wise, how are these courses structured?
I guess I'll continue. So what I hope they take away from, I guess, the computer architecture class are, I guess, the nuance of moving information from one spot to another by machine, and how you can go about making that movement very efficient. That kind of, I think, sums up the grand scheme of it, which to me always seemed, or before the course seemed rather mundane, but when you consider the details of things like loading data from memory, putting it back into memory, operating on as many things as you can at the same time, it actually gets quite interesting, and I think rather difficult to imagine that such seemingly simple concept, simply organizing data and moving it through a machine, an otherwise sequential machine, or at least maybe put it this way, an idea that's expressed in a sequential manner, at least your code is turned into a sequence of instructions, to then try to parallelize that in an automated fashion, I think is really interesting. So if students can actually grasp that, that would be the deepest thing that I could think of. And there's many techniques at a number of different levels to try to do that. That would be great. So in this particular class, the evaluation is pretty simple. It's just midterms, a little paper review project at the moment, and a final exam with also quizzes in between. The other class, the digital VLSI class, is much more project focused because we want to expose the students to, I guess, a more realistic experience in how to actually building large systems. So in that class, the students are not only asked to use industry standard tools by which to build chips, but they're asked to apply them to a project of their own invention. So that's perhaps one of the challenges of the class, that the students have to come up with something interesting to do. And they have to do that early, and then there's a lot of work because not only are they getting introduced to the tools, the course also has a broad spectrum in the sense that parts of it you're looking at literally what one transistor looks like and how to construct it. And at the other end, you're looking at how is it that I can describe thousands or hundreds of thousands. And if your design insight is good enough, this is something that should be able to scale into the millions of billions of transistors. So it's a broad scope, and it's tested by 2 projects, number of difficult labs, and also a final exam to make sure you've got some fundamentals down.
Yeah, so I think in my course, evaluation will be similar. I think, let's say for 3311, if you took it with me, I think, well, assuming that we are still running online, but in person could be slightly differently, but evaluation, pretty much the same idea. So let's say if you run the 3311 online, then maybe weekly quizzes give you a little bit more pressure just to maybe push you to study about the lecture materials maybe every week, and then spend about 15 to 20 minutes to complete a quiz to really test your understanding. So I think that's a valuable thing to have, even though you might be having the pressure, every week. Um, and then we got labs, of course. Labs would be really really get your hands dirty, right? To really learn about, try to apply what you learn in the lecture, and then to put into programming after, or even though it's software design, but you have to know how to program for sure. And then, yeah, I think the most fun part usually students have is about the end of semester projects, because you learn about a number of design patterns, about how you can apply code architecture for different problem context. We learn about maybe 5 or 6 different patterns, and we don't actually tell student which pattern you can use. So it's completely up to your judgment to see which one you want to apply. So you can really pretend it's really like a workplace problem to solve by your supervisor, and then write a report at the end to also explain your rationale about the design and implementation. So I think the project is really the big takeaway for the course. Unfortunately, since we are running online, so last semester we didn't really allow for teamwork because it's really difficult for students to coordinate with team members. But later on, eventually we'll return back to campus, hopefully soon. In that case, I think finding some good partners, to work together, I think that's also very important, like soft skills you should really have. I think looking forward to it. And then for 3302, the compiler course, in case you want to take it as an elective, I think, yeah, just normal, we got lectures, we got some quizzes, we got mid test exam. I think the project component will be even more, even heavier, because it's really, there are many different stages for developing a language compiler. You have to talk about design for the language, and then implementing the tools, writing the report. There are many stages. I think that one will be even more team project heavy. So yeah, I think that's really the best way for you to learn as you struggle through the different stages. Yeah.
I think this is a question more so for Prof. Sebastian. If
Yeah.
there's an issue with the course or professor that students are facing that hasn't been resolved, who can they contact in the department, and what is the right approach?
So am I to assume that the student already spoke with the prof? That would be the first step, if you feel comfortable speaking to the prof. If you do not, for whatever reason, then the next step is that you would contact me, or if you're in engineering, an EECS, and you would describe the problem. And then I would typically probably either try to get more information from you, or then forward the issue anonymously to the professor. When I say forward, I mean just communicate with them, if it means perhaps taking a snippet from your email or something like that. Again, anonymized, that's what I would do. And so that would be the typical start to the problem, to the process by which we try to address the problem.
Just to mention the Declaration Day packages that we made for you guys, it has all the contact information for EECS department, so the email and the QList, I think the web page that leads to the QList link. So it's linked somewhere in the package, so you guys can take a look and find it there.
Okay. So it's kind of to follow up on the earlier questions. You guys mentioned fundamentals and good programming and even soft skills. But what advice would you guys have for students that want to prepare themselves for taking these courses in the future with you?
Let's see, for me, I guess the first part would be when you, I mean, it's perhaps very general. So are you talking like technical background, or I guess perhaps maybe the question can be, oh, let me just give it a shot in one way, I guess, and see if I hit the mark on it. And that would be, if you encounter a problem, try to solve it. If you can't, then contact the prof or whoever it is that's there to help you with it. And then as you contact them, be able to try to solve the problem to the point where you can, in your contact, say, I looked at this, I tried this, it doesn't work. I looked at a problem, I don't know where to start. Try even a seemingly ridiculous start. I took the information, I added A to B, and I have no idea where to go from there. So at least it gives us a starting point to talk about your problem, where you're coming from. Even that effort would show us, would show me how good your initial understanding is. It might be might be the case that your starting point is actually excellent, and then there's just a misunderstanding at some other point. So that would be it. I think in a way, perhaps that boils down to the ability to demonstrate some independent thinking, and then as clearly as you can, communicating your misunderstanding or confusion.
So the next question will be for Professor Jokiwang. Students that come with no programming background from high school or any other previous educational institutions, or transferring from another program, what do you advise them to do for being successful in future programming courses like EECS 2030 and 3311?
Yeah, let me speak about maybe these two courses separately. You're definitely gonna encounter 2030 before 3311. Let's say for 2030, it's the first course you will take in the second year. But I would say in the first year, you'll be taught from scratch. So for engineering, you'll be learning about MATLAB in 1011, and also being introduced to OO programming in Java in 1021. So I would say if you really have no prior background, you don't have to worry, you are not alone. For example, when I started my CS degree, in my year, I didn't know anything about programming. I didn't do that well in the first year, but I think things will really start to maybe click, usually from the second year. So if it doesn't click on first year, don't worry, you're not the minority, you're not the majority, you're not alone, let me put it that way. So how can you get prepared? I would say since your first year, 1011 and 1021, they kind of give you some engagement components. You know, you can try to program with a fidget board, maybe the the heart rate monitor, and also the servo flow controller, etc. I would say those components are very much fun to really to see the programming effect on some physical device. Very promising. However, on the other hand, I would say when you are doing your first year programming courses, try to get into the underlying logic about how you program. For example, when a piece of program actually works or it doesn't work, try to see if you can really trace the program. So tracing the program is a very important technique to really pick up. That's why. So currently, I taught 1021 back in winter 2019. So the majority of my students, they simply didn't got any programming experience. And yeah, so I think I taught them from scratch. And I told the number one thing I told them was, whenever you got any problem for your program that you don't know how to move on, like what Sebastian suggested, try to solve it with yourself a little bit and try to see exactly where you're confused and try to explain to your TA or maybe a professor, and then see how your professor will actually lead you to the solution. The wrong question to ask your professor or TA would be, oh, how am I supposed to solve this? What should I type? So I think typically they don't like this kind of question, right? They would like to lead you to the solution. So for 2030, I would say you don't need to have any special preparation as long as you do your homework and try to dig into the programming exercises for the first year, 1011, 1021, you'll be okay for 2030. But if you took it with me, you will be given some tutorial exercises. You'll be taught from scratch as well, so you don't have to worry. 3311 could be a little bit trickier, right? Because 3311, actually, if you look at the course learning outcomes for 3311, it's quite a course that will synthesize many things together. You have to know about logic. You have to know about OO. You have to know about basic also programming. Also, you will be given some substantial projects. So many things. The good news is you will never be perfectly ready for the course. It's not possible, right? So you don't have to stress yourself too much. On the other hand, I would say just make sure you learn very well in 2030 about the object-oriented programming. And also 2011, I think that'll be the course you really want to focus more. So that's so-called an interview course because you're going to learn about many data structures and algorithm. I know some of my fellow faculty, they might focus a little bit more on the theory part without giving you too many programming assignments. I would say if that's the case for you, you may just want to do a little bit more extra problems. You can easily find extra data structure problems on the internet and try to practice with them. I think if you get a very solid grasp of the programming ability, then you'll be fine with 3311. Yeah.
Okay, awesome. Just to clarify, 2011 is the data structures course.
Correct.
Okay, perfect. So kind of moving away from the courses and more just asking as people, what would you say was the deciding factor on, I guess, why you became engineers in the first place, or more specifically in the EECS side of engineering? What drew you there? And I guess if you could do it again, would you make the same decision?
For me, I don't remember exactly. I think my mom tells me I apparently wanted to go into history. I thought I was just better at technical subjects. I think at first I wanted to go into mechanical engineering because it looks like there was a lot more moving stuff there. But I think my impression was that electrical was a bit more math heavy and I was good at math. I don't know how big of a difference that made. So in any case, I went into it. I always liked, I think, technical subjects. So in high school, I was good in math. I liked physics. I wasn't so crazy about biology. I like biology a lot more now. I'm much less interested in physics. So stuff changes. And so that was me. Was there another part to the question as far as, oh, would I do it all the same again? Yeah, I would do it the same. I think that engineering teaches you a certain rigorous way at looking at things. It teaches you how the limits of inanimate objects, how they come together, and so I think it gives you a more realistic and I think working impression on how other things can be constructed as well. So that part is good. I would say that the humanities aspect to engineering is a lot more important than I had given it credit for before. So this ability to kind of master or understand the inanimate world is fantastic and extremely helpful. It really has to be coupled with at least an attempt at perhaps teaching, informing people about the softer human side as well. I think with those two things, you'll be an excellent engineer.
I think for me, I think I would actually make the same decision. So before I chose my university major, I thought I'll be interested in economics. And my parents actually told me that, oh no, you wouldn't learn anything from economics. Well, of course, that's not true, right? You will learn something from any major, but my parents told me that, yeah, you just try something more technical. And then I chose actually not EECS, not computer science in the first place. I chose information technology and for the first year. And then yeah, I took some interesting course in Java and HTML, but I found that there may not be enough substances, not too many problem solving, so which I don't quite like. So that's why I switched my major to computer science. And then I really like the major, EECS in general, because you can really solve some substantial problems, either on your own or maybe to collaborate with your colleagues. And then to really get something done, that's really important. I don't like to simply just have endless meetings, in your major every day, just to talk about some case study. That may not be just doesn't fit my personality. But I think when I really decided to really focus more on software engineering. Actually, after 3311, actually after I took the software design course, because when you are given a substantial software projects, especially the problem typically is open-ended, which means there's really no right or wrong, answer, but you would just have to know what you're doing and also to justify whether you have applied the right patterns or right design principles and etc. So I would say, yeah, I would have chosen the same major. Yeah, for sure.
So the next question will be, what advices do you have for students that are not entering a normal year and entering their second year, which is considered to be the hardest year?
Yeah, that's the hardest one. What advice would I have for students entering the second year? Well, I don't know why is it the hardest? I mean, I don't understand.
This is basically like what we students think. I'm not
Oh
sure.
yeah. Well, I'd have to know why you
Generally,
think that because
I
I could
think
I could
it's
clarify a bit.
yeah.
So I think the in the first year, you still kind of reviewing the concepts from the high school and making sure everybody has the right basics. And a lot of it is kind of review for some people, and for other people it may be new. But when you get to the second year, it's like everybody's on the same plane again, and it's your first real actual engineering course, where you might have projects and stuff like that.
Hmm. I see. Okay, so you're finding that hard. Bottom line is you're definitely getting the impression that it's hard. And is it the concepts are hard? It seems like a lot of work.
yeah. So it's more so about, in general, we find it hard, but now that students are not having a normal year, everything being online,
Oh yeah.
all entering second year, and they're not sure if classes will be online or in person. So how will the transition, and what advices do you have for them?
Um, I don't think I have really anything profound. I just have simple things. If you can organize, plan ahead, um, work hard. It's stuff you guys have heard of. I've probably heard many people say, right? And you certainly might feel like you're working hard. I mean, I guess one thing that um, from my own experience, I guess I could say is that when I was young and I thought I was working hard, I wasn't really working hard. So I think it's just one of those things you have to suffer through, like um, procrastinate until it just hurts too much and you're going to start planning. I am kind of a believer in experience. So if it hurts now, it's actually, I don't know how else to put it, but maybe it's supposed to hurt. Because I mean, that's kind of what happens with life. It's just not, let's say, I don't want to say it's not easy, but it's, and we wish things were easier. And certainly I wish things sometimes didn't take as long or they were some problems were easier to solve, but I guess for the moment I'm taking what some people might call a holistic look on it and saying that perhaps that's just the way it's supposed to be. If you want to make it a little simpler, I would say try to imagine the future a bit more. Perhaps you are, I don't know, but in the process of doing that, it might inspire you to plan and arrange things a little bit more coherently so that what would otherwise be a very difficult thing, cramming for something at the last minute, trying to understand something under a lot of pressure might be a little easier. I say all of this appreciating that from what I've heard over the months from students, especially online, is that people are working very hard. So but I don't have any kind of anything else that I can think of at the moment that it could be maybe what they would call a silver bullet answer.
So just a general question for you both. How is online teaching this semester, since it's new for you too? Well, last semester was the first one, but
Well, speaking for me again, is yeah, it has been a lot of work, a lot more than I thought. I thought it would actually be perhaps easier, but it's been way more work. The teaching has been uh, much more time consuming online, preparing lectures and following the advice of education experts for online teaching took a lot more time. I'm not certain if the payoff was as I expected. Um, so that's the first thing. I think in some ways my experience can resonate with the students. If you guys are saying it's taking a lot more time, it certainly happened to me.
Yep. I think for me, yeah, similar to Sebastian, I think teaching definitely, we are also working hard, just like you guys. So it's fair, right? I think in terms of the teaching, I would like to share some experience over here. So I would say, for example, for 3311 last term, actually for the same course, I taught about 5 or 6 times before last fall. So it was my seventh time teaching the same course. I would say since I was able to record the lectures for the student to watch because it's more like online setting, and then I was able to record actually better quality of lecture because typically if that was in person, I might be we might be distracted by something else, or maybe sometimes when I said something not in a very perfect way, I simply just let go, in the lecture room, and I just simply move on. But when you're recording your lecture, you try to be as perfect as possible. So you would may not believe it or not. In order for me to record like a 3 hours of lecture, it took me at least 6 hours, double the time. But I think that that's good for the students. On the other hand, I can appreciate from the student's perspective to really watch 3 hours of lecture just for one single course per week. I can see that's really it's a it's challenging to really split your time because if you only do the 3 hours, I know many of my students did it. It's interesting. I thought to myself, if I set a quiz to be open for submission for an entire week, then student can simply choose the time that they can do the 20 minutes quiz and then plan their lecture. Ideally, I'm a very optimistic person. But based on my experience last term, every time when I look at the number of submission for a particular quiz, until Thursday evening, we only got about 10% of the class actually who have submitted the quiz, which means all of the people, they're only watching the lecture maybe about 2 or 3 hours before the quiz deadline and then try to submit the quiz. I would say that's kind of a pity, but I know everybody's learning how to do online course. So also go back to your first question actually about what advice I would give to students. I would say, hang on. We really hope that we can go back to campus. I can tell you that given that online teaching is so laborious for your professor, they hope to go back to campus much more than you do actually. So they really hope to resume the normal teaching and then really to interact with you. So my advice for you would be, uh, really try to do the best you can. Of course, there might be certain understanding that you couldn't really get because it's completely online. You may not be able to get the attention from your professor or from the TA. You are pretty much alone. I know that, but your professor will know when we resume back to campus. And then hopefully one thing that you can pick up, try them up as the soft skill you can pick up will be time management. Hopefully, as Sebastian said, you only learn when it hurts. So I hope that hurts everybody last term very much. I heard many complaints from students about how much stress they got. Totally appreciate it. But I think it's a lesson to learn. We are learning as well. Your professor also procrastinates, so don't think they're not procrastinating. They are, right? So I think everybody's learning how to manage time. Hopefully, when we resume back to campus, once everybody can see each other, and with your improved time management skill, hopefully things will be just okay. Hopefully.
So, Professor Jackie Wang, has it been easier for you to transition since you already did a lot of online recordings before?
Yeah, so I would say to that respect, yes, I did my recording ever since I started my teaching. Actually, since students like it, so to me, that part didn't require me any effort, so I was able to. On the other hand, there was something I can share with you actually. If any one of you who might be a teacher later, I think the one thing that's really hard to keep up is to being very responsive to students, right? So the course I taught 2 sessions last term, so maybe 350, close to 400 students in the very beginning. So I think to respond to the emails to students, that would be the most stressful things because each email might require a little bit of work, before you can respond back to the students. I think that might be the more stressful thing I didn't expect when we switched to online teaching. But I think yeah, but I'm lucky already because for lecture recording, tutorial recording, I was already doing that, so it didn't take me much training to do. Yeah.
So for students that are looking to enter this field, what would you recommend for them to participate in or do in their own free time in order to get more exposure before actually going in?
Well, I guess these opportunities aren't open to all, but I mean, you could try for a summer research position. Um, there's also, I guess, there is the internship or co-op program that the university or Lassonde runs, but this is obviously something that you normally do after second year. So, good. I'm trying to think what I did. I mean, I was interested in stuff, and I, uh, I guess for me, in my case, after second year, I did spend summers working for another prof in the lab, and I felt that that was helpful. So he had us do things like, for instance, write a little circuit simulator in second year. Um, third year, that really helped me because that helped me get started for a fourth year project. By between third and fourth year, I was writing some stuff for CAD software. It was pretty simplistic, but it was a good experience. So that's how I got it. Otherwise, I guess are there nowadays things? I mean, that was a lot of this was pre-internet, right? I mean, I didn't get my first email until second year, so the communities that we had to be kind of cobbled together practically physically, like who you knew, who you spoke to directly. Um, I suppose nowadays there's a lot more virtual communities that could be formed um, and things pursued, whether you're putting code on GitHub, this kind of stuff actually translates to physical work as well, or going to a maker space even, and getting a sense of how other people are just hacking things together, and maybe something that you could apply your progressively increasing theoretical insight from school could be extremely helpful to you.
Yeah, I have the same suggestion as Sebastian just said. I think doing summer research will be very beneficial for you because when you graduate, you can either dive into industry or you want to go to academia. So it might be a nice try for you to see if you're the kind of a person for academia that you may want to do research. Let me speak about my experience very quickly. So I think at that time when I was here, Lassonde wasn't here, of course. It was back in year 2004 or 3. So I was applying for the summer research for the EECS, but my GPA wasn't high enough to really get in. However, my supervisor at the time, he actually suggested, you know what, rather than being paid, to answer, to do research, why don't we do a project course so at least you can get some credits? So I think it's a very good thing for you to consider. Let's say if you apply for the Lassonde summer research program, for whatever reason, if you didn't really get accepted, don't be too upset. Somebody has to be accepted and somebody has to be rejected. So it's just the way it is. I would say if you really get rejected, just still get in touch with your potential supervisor, and then to see if they might be willing to maybe take you as a supervisee and then do the research and possibly take some project course at the same time throughout the summer so you can get some credits. I think doing a research project course or like a summer research program is very beneficial for you, especially when you want to apply for graduate school. So when I was writing some reference letter for my previous students, I would say typically if you only have completed some, let's say, projects, let's say in 3311 or in other engineering courses, those projects are not really substantial enough for you to really say in your personal statement when you apply for graduate school. You really need something that will take you at least 3 to 4 months to really complete, and then you can talk about it in your personal statement. So that's definitely something I will recommend.
So usually students are very good with prerequisites and checking if they have it when they're taking a course. But sometimes the GPA requirement for EECS courses like 4.5 can be confusing to some people. When does it actually apply and when is it calculated, if Professor Sebastian could expand on that?
I open up I go to a website and I look at what your and there which has a record of your. Oh, so how it's calculated? Oh, we've got a program that automatically scrubs through your marks. Um, uh, that should be before you're de-enrolled, that should be looking at, I believe, but I don't know for sure because I've never actually seen this program, your most recent marks before the de-enrollment. So if it's run, in early January, before a de-enrollment message is sent, it should be seeing everything you've got until that moment. My interface to it is, via another website that we have for administrators. I log in, to see what your GPA is. I would put in your student number, and then I see your entire record. And within that, there's a table that says CSE GPA that looks at only the EECS courses that you took and calculates that GPA. So your overall GPA might look good, it might be above 4.5, but it's that CSE GPA that only calculates the subset of marks associated with your EECS courses that we look at to enforce that 4.5 rule. So at least those are some of the mechanics behind it. There might have been, I think, another question in there that I didn't answer. But
so when is it calculated usually?
Oh, it's calculated early in the term before we do any kind of de-enrollment. So there's a check after all of the marks are ostensibly submitted. So we hope that everybody submits their marks, for instance, by the end of December. And then we run the program a few days after that. That looks at all of the marks submitted to calculate your most up-to-date GPA. And based on that, in early January or in late April, if you're talking about the summer term. Based on that, then it would flag any students that don't meet GPA. So what happens is I get then a spreadsheet that lists all the potential de-enrollments that students are facing because they either don't have the course requirements, like you say students are usually pretty good at that, or I see a field saying GPA low. Hopefully that kind of answers it a little bit. So early January, for instance, as far as the winter semester is concerned.
So just for clarification for the students, since they're new, so it's after every semester. So
it's essentially after every semester. That's right. That is right. After the final marks are in.
Yeah, that's all of my questions.
Mm-hmm.
Okay, so I think, we've covered a lot of the questions that have been submitted, and there's no way we can do them all because there's so many, and, both of you have really, really thoughtful answers. But I just like to open the floor now to the audience and just, normally when we're running this event, each department basically has like a booth or a table in the main hall of Lassonde, and students walk around and, interact with upper year students, professors, graduate students, and just ask, any sort of question or, dialogue they want to have, curious about it. So, I'll just ask that any participant raise their hand and ask away. And I see that we have 2 hands raised right away. So yeah, I'll just start with one of those. Let's see. Keith Lee.
Hello.
Hello. Yes, I can hear you.
Okay.
Go ahead.
I was just wondering, where would you find these like summer research opportunities? Like I heard something about Lassonde, but I'm kind of like unsure of like how do you go about that, and how do you would apply for something like that?
Okay, so for sure, there are some programs that Lassonde runs. So Lassonde Advising would be able to definitely help with those. As far as giving you more details about these programs, how you apply. But for instance, for sure, there's the NSERC Summer Undergraduate Research Program. And then there's, I forgot what the Lassonde version of it, but there's in essence kind of 2 programs.
Lura.
Sorry?
I think the Lassonde one is called Lura. Lura.
Might in a sense actually be kind of conjoined as well, but I think they're 2 different but related opportunities, and definitely student advising should be able to give you info on that. I believe that for those particular things, if you're aiming for the summer, you would probably want to get an application completed by you better talk to them within the next week or 2, because you might need to get it done by February. and end of February or mid-February. So that's one thing. The other thing is just to possibly look at profs whose research you're interested in and just contact them. There's nothing stopping you from doing both things at the same time, but let's say you looked into it, or either this Lura or NSERC attempt didn't work out. You could say, hey, I'm happy to try something out for the summer. Do you have anything to do for me? Here's my background. Here's what I'm interested in. Here's the courses I found interesting. So that would be just simple, looking through websites. In a sense, I forgot, I think, when I was I think another student probably told me about it when I was an undergrad about these NSERC summer programs. So I remember just applying for those sometime in the winter.
Okay, thank you so much.
Yeah.
And I put the links for both the NSERC and the Lura in the chat. So I think definitely fill those out. Last year, we knew many people who filled it out in first year and had a position in the summer. Like, you don't have to be an Einstein or a genius to do this. You just have to show interest, essentially. Okay, I see another hand raised. Joaquin, I guess we'll have.
Yeah, hello. Can you guys hear me?
Yep.
Okay, so my question is regarding also about the actually regarding about the research and co-op. I want to know what are as the electrical engineering department, what will we be looking in the research, like what type of things specifically, like research about what and working in which field and what things we will be doing.
Oh, well, I mean, it's supposed to, as far as, well, how do I answer it? In a sense, because the program is accredited, it has to give you exposure to a certain kind of a reference in electrical engineering that is common enough for the field, right? So the accrediting bodies could say, yes, you've covered the main parts of engineering. So those parts are complex systems, so certainly circuits, this would be the traditional thing, but also the types of work that those systems have to do. So this includes both work on information, so information processing, signals and systems, and also work like physical work, like literally moving things or providing a great deal of energy, i.e. electrons, and moving things over great distances, i.e. electromagnetics. So those are the kind of the essences of electrical engineering. The essence, the reason being that what we kind of ultimately work on, electrons, are these little bits and pieces that are easy to move and extremely powerful. So the electrical force is the most powerful and accessible force we have available to us. Obviously, nuclear force is very powerful, but not so easily accessible. Okay, so that's kind of a long-winded answer that we kind of do what we're supposed to as far as covering the basics. But what this particular department has specialized in, and hence these, you could, I guess, assume that these specialties, the content and the insights are somewhat amplified in a program, would be, you could say, probably four things: signal processing, electronics, energy and power, and medical devices. And the fundamentals of electrical engineering that each of those specialties tap are obviously covered by the profs, but you could imagine that as they're expressing those fundamentals, their deepest insight comes from those four fields: signal processing, electronics, power and energy, and medical devices. So
does that mean we'll be seeing stream soon in
not that I'm aware of. The resources certainly don't allow for it. Actually, well, let me back off. What do you mean by soon?
Few years, not next year, for sure.
Few years, I would say the opportunities look high because we are in the process of hiring many new faculty. I think there's at least 5 or 6 searches for faculty. So this will expand the resources, I think, to an extent that will allow at least people to then regularly deliver program offerings. You see, that's kind of the issue of delivering streams, that once you commit to a stream, then you're committed to delivering that stream every year. Otherwise, I mean, you don't really have an official program if you just offer it every other year. But if the enrollment is too low, or if the profs need to then be directed to courses where the enrollment is high, that's introduces a big resource gap. With more people, certainly even on the faculty side, and I assume on the enrollment side, although I think that um, um, engineering enrollment hasn't gone up as much, whereas it's skyrocketed in computer science. But nonetheless, if you have more essentially faculty bodies that you can direct to problem areas, then that gives you a lot more freedom to offer streams. So I can say with this pretty large amount of hiring that seems to have been scheduled, I'm optimistic that within a few years, streams are going to become a reality.
Okay, thank you for answering my question.
Okay, I'm just gonna stop the recording now and just end it, because we'll just leave the floor open for an informal talk. And if whoever has to make it out by now or leave, thank you for joining us. It's been about an hour now, but if you can stay, you're more than welcome to stay. This event is allotted until 6. I don't think we'll go all the way till 6, but whenever we feel that I think we've hit the discussion, we'll be ending it.